How's the temperature? Is it getting any cooler in here? Or is it about the same annoyingly warm level?
Feels good.
Decent? Is that thing breathing? A little bit? Okay, good. Good. Fantastic. Now, we dealt with craps in 105. I don't want to deal with craps again. Although craps is wonderful. It's fun. I use craps on the quiz for next week. The actual distribution you'll be using is craps, which means you'll be using the 49.2% chance of winning at craps, which is fun. It's a fun number. You might wonder where that comes from. I think I explained it to you on the quiz. You guys learned it in class last term. I want to use a different game right now. It's called Chuck-a-Luck. Chuck-a-Luck. So the way Chuck-a-Luck works is similar to craps. It's not quite as popular. I don't know why this one didn't catch on and craps did. I think it's because craps gives the illusion of being more complicated than it actually is. And plus this involves 3 dice, and maybe that somehow, I don't know. But here's the deal. You bet. You bet on one of 6 numbers. 1, 2, 3, 4, 5, or 6. You bet on that. And we're going to make a $1 bet, just to keep things simple, although the payoffs become multipliers of whatever you bet. So if you bet $1 and Chuck-a-Luck pays 10 to 1, you'll get $10 back. If it pays 10 to 1 and you bet $10, you'll get $100 back. So it's a multiplier. We'll just use 1 to make the math simple. So you come up to the table with the terrified looking lady and you place your $1 or your chip on one of the numbers. And then she turns this thing called the bird cage, which has 3 dice in it. Spin it, 3 dice, and the 3 dice fall on the bottom of the bird cage. And then what happens is you win money based on how many of your numbers show. So suppose you bet on 5, just to pick a number at random. I put WLOG without loss of generality, which means you bet on 5. If you bet on 5 and no 5s come up, you win -$1. Now explain that to me.
You lose your bet.
You lose your bet. You bet $1, you didn't get any numbers, therefore you got no money back. Fair enough? Hope that's fair. Good. If 1 5 comes up, so you got like a 5-3-2 or a 5-2-3 or something like that, or 5-6-6, you should have bet on 6s, but 1 5 comes up, you win $0. That seems a little weird too, doesn't it? Winning $0. That just means that they paid 1 to 1, right? If you bet $1, you get $1 back, which means you wipe the slate clean and you keep going. Or maybe you stop. But maybe you don't. Suppose you get 2 5s, like 5-5-3 or 5-5-6 or something along those lines. Then you win $1, which means the payout was double, 2 to 1. They gave you $2 back, you spent 1, they gave you 2, you profited 1. Fair? Good. And then suppose you get the sweep, 5-5-5, you bet on 5s and get 3 5s, you profit 9, which means they handed you $10 back when you bet 1, which means you cleared $9. Fair? My question to you, on average, over time, how much do you win? $1, 0. 0, $1. Okay, I'll take guesses. Let's write them down. We got on average, average winnings. Average winnings in Chuck-a-Luck. Okay. 0. 1.
-1.
-1.
1.5.
1.5. 150. Love it. Anybody gonna say 62? Probably not. I like these guesses. They're pretty damn close. Should we average your guesses and see what that comes out to be? It's like 60 cents or something like that, somewhere in that neighborhood. Good. So suppose, why would you want to know that? Why would you, and when I say you, I'm using the pronoun you in a very general way. Why would you want to know that? On average, how much you're going to win? Zach, go ahead.
You know how much money you want to get out of the ATM?
You see? Damn it, Zach, I taught you. You accept how much money you want to lose and put it in one pocket. Good. To know how much money you want to bet. Good. Very nice. That might tell you how long you're going to be able to play. So suppose, for example, you figure out you're going to average a 10-cent loss every 5 minutes because you're playing slowly. $1 then will last you, what, 50 minutes or something like that? So you can play like $1 will last me an hour. Like, yeah, it's free drinks. Good. Now, if I apply the word you to Vegas, why would they want to know this? To make sure they keep track of how much they're either going to lose or win off of you. Yeah? So Vegas wants to know this too. They want to know how to control, they can't control the dice falling, but they can control how much they pay you for the dice falling, yes? More on that momentarily, more on that momentarily. So, can we get a more precise, these are wonderful guesses, I love these by the way. Can we get a more precise average than just guessing at 0 or 1 or -1? Can we get a more precise average?
Yeah.
Of course we can! All we've got to do is set up the distribution. Just set the table up, yes? We know what the payouts are. The payouts are here. -1, 0, 1, and 9. Okay? Did anybody average these 4 together? That plus that plus that plus that divided by 4? You could do that. Mathematically you could, right? And if you do that, you're going to get 9 divided by 4 is 2 1/4. 2 1/4 or 2.25, I think. 2.75. Okay, 2.75, which means on average, we're going to walk away with $2.75 per game. But the problem with that logic is, what does it assume? If you just add these 4 up and divide by 4, what does it assume about these 4 outcomes right here? That they're equally likely. Yeah? It's like having a 4-sided die. One of them says 0, one of them says 1, one of them says 2, one of them says 3, and you roll that die across the floor. And if it comes up 0, you lose your $1. If it comes up 3, you win 9, and so forth and so on. Is it like that? Probably not. So what is it like? Let's go over to the sideboard. Let's go over to the sideboard. Because this is also going to bridge a gap for you guys for next week. One of the projects you get to run for next week is related to this problem here. So X equals your payout for Chuck-a-luck. And we'll get this started before the break, and we'll let it, because it has an Excel spreadsheet that's attached to it. So we know the payouts are -$1, these are all in dollars. $0, $1, or $9. What we need to know are the probabilities associated with these payouts. We need to know what the probabilities are. If we know the probabilities, we know the weights, and we can run the weighted average. Now, the first guess we had was it was 25%, 25%, 25%, 25%. How do we feel about that? It's probably not right. I mean, if you think about it yourself, imagine 3 dice in your hand. Throw them on the ground. Is rolling 3 5s going to be easy or hard?
Hard.
Probably hard. 25% is not hard. That means if you do it 4 times, you're going to get it one of those 4 times. I don't think it's going to happen 1 every 4 times, unless your dice are fixed. How often is it going to happen? Once every how often? Guess this. Once every how often? I heard 100, I think. 1 every 100 times. You could actually give me a number.
216?
Madeline. 1 every 216 times. How the hell did you know that? How'd you know that? Because she did 6 times 6 times 6. The same thing you guys did on Tuesday with 2 dice. Remember the 36 we kept dividing on Tuesday with 2 dice? Why was it 36? 6 times 6. So to get 3 dice to all say the same thing, it's like snake eyes on 3 dice. 1 6 times 1 6, it's 1 and 2 16. So we'd have to do it 216 times until we expected to see 3 5s. Is that fair? Where it gets more interesting is when we start working backwards. When we start working backwards. And I want to come back to that. I want to come back to Madeline's argument backwards. But while we're thinking about that, and when we take our 5, because you guys are definitely getting quieter now, I set up Excel to simulate it for us, to save us the time. So we'll get this started now for break. And then we'll come back and discuss the numbers that we're seeing. So, grab it here. Here's Chuck-a-luck for you. So what it's going to do, it's a little too big. There we go. It's going to roll 3 dice up here. And it's going to keep track of how many 5s it sees. So I want to press F9 a couple times here. Okay? Notice it's keeping track. Every time, like right now, there are no 5s up there. It's a 3, a 1, or 4. So right now it's at a 1, which means we got no 5s. Right now, none. 1, 2, 3. There's 1, and then 2 non-5s. That's why this guy went up by 1. So if I just sit here and hold this bad boy down, what you're going to see is, you're going to see that graph update over time, and it's keeping track of the percentages. Let's see if Madeline's 1 and 216 shows up. And then when you guys come back from break, let's also see if the other percentages up there make sense.
We're already past 216.
That's okay. I want to let it run for a long time. We can do a... So, Zach said we already passed 216. Love it, sir. What does 1 and 216 mean?
On average over time.
Whew! I'll see 1 out of 216 on average over time. Is it a promise every 216? No, it's an average after every 216. So that's what we'll do is we'll come back to that. I'm going to let this run for a while. You guys take 5, and we'll come back and see how it's looking. And then we'll actually analyze it some more after I found my stapler.
Let's stop.
That's because I have to hold it down with something heavy. If I would just learn how to program in VBA, this would not be a problem. There we go.
Teach yourself how to do these.
Yeah, this is just fun. I mean, when you're a math geek and ADHD, this is like the best tool ever. Because it's like limitless simulations. I never did, Sean, get to simulate the damn coin flip. I ran out of time. Coin flips till heads. I wanted to simulate that one for you guys too, but ran out of time between Tuesday and